Hi, this is Travis, and I want to tell you about a data science technique that you can use to optimize your product's feature set and pricing tiers so that it wins a maximal amount of market share. And we can do this quantitatively. We can do this using customer survey data to inform our product design decisions. So the method that I want to tell you about is called choice-based conjoint analysis. So let's break that down. Conjoint, the premise behind conjoint is that a product is made up of constituent parts. It might be feature A, feature B, feature C, and then price. And customers ascribe differential values to these different features. And if you sum the constituent parts, that the values across those constituent parts, then you can get a total value or attractiveness score for that product. And this plays into how likely customers are to purchase that product, right? A product with a higher amount of value, customers are going to prefer and are going to be more likely to buy than one with less value. So that's the idea behind conjoint, is to break products down into its constituent parts and to find the value that customers ascribe to each of those parts. And so actually, let me just show you an example of this, right? So we have, let's say that we're working for a cloud platform like Google Drive. And when you think about this B2C platform, you can break it down into different features. So the amount of cloud storage that they have, whether or not you have access to customer service, the different cloud services that they offer. Is it just email? Is it email and video call? Or is it email, video call, and then productivity tools like Google Docs? And then the different pricing tiers, right? $6 a month, $12 a month, $18 a month. So we've broken this product down into its constituent parts, and these are called attributes. And of course, these attributes have levels, right? They have different levels, each of them, right? This has 3 levels, this has 2 levels, this has 3, and this has 3. That's the idea behind conjoint. Now, the choice-based comes in when we're actually thinking about the way that we're going to ask these survey questions. So what we do is we present multiple product concepts at a time in each question to the respondent, and we ask them, which would you buy? And each of these product concepts, and these are called alternatives in this type of study, has varying levels for each attribute. So for cloud storage, this cloud platform A has 30 gigabytes, this has 2,000, this has 5,000. Customer support, no, yes, right? Different cloud services and different prices, and the customer has to make trade-off decisions in order to tell you, as the analyst, which one they're most likely to buy. This has advantages over normal questions. If you're trying to get the importance of the constituent parts of a product, maybe the naive way of doing it is to get a Likert scale rating for each of the features, and then for price that we see here. But the problem with this is that a lot of times people are choosing 6 and 7, top box and top 2 box, and they pretty much ignore the entire bottom half of the scale. This is a well-known response bias that whenever you give a respondent a Likert scale, they're going to skew positive. That is well documented, and I've run into it many times in my practice. Well, that's great, but really it exaggerates the importance of these features. And then also, if everyone's giving all of these features a 6 and a 7, on the back-end analysis, it's going to be impossible for me as the analyst to differentiate between which feature is actually more important. So this is why it's preferential to show these product alternatives and then to get one preference rating so that the respondent has to make trade-offs. So coming back around, we're going to get a utility score, or how much value these customers give to each of the feature levels. We're going to get a utility score for each feature level here. And we're going to know the relative importance between these feature levels, so we can decide as product managers which features to prioritize. Also, the really cool thing about conjoint analysis is that you can actually create, with the statistical model that I'm going to show you at the end, you can create a market simulator, which is where you define a competitive set of product alternatives and you introduce your product into this market, and we can predict the market share that each one of these products is going to win based on our customer responses and their choice preferences. Okay, so I just want to review some terminology really fast. So looking over here, we have 3 product concepts. Okay, each product concept is called an alternative. And then each of these alternatives is defined on the constituent features, and we call these attributes. So we are showing 3 product alternatives per choice-based conjoint question. And each of these alternatives is defined on 4 attributes. And these attributes have levels, as I just described before. Here are the levels of the attributes. Okay, so when you think about designing your CBC, I'll start calling it that, choice-based conjoint study, as the researcher, you have to define 3 parameters up front. First of all, how many attributes per product alternative, right? So in this case, we have 4 attributes. You can think of many other ways to define your products against, right? We're just using cloud storage, customer support, services, and price. You could think of, like, brand is another really popular attribute to include. What else? Maybe another attribute would be number of users allowed on a subscription. Is it a solo subscription, or is it more of a team-based subscription where you can have up to 5 users, or maybe it's enterprise level where you can have up to like 1,000 users. So these are different features or attributes that we can use to describe our product, but you have to think up front, how many attributes you're going to include and how many levels are going to be in each of those attributes. You have to remember that you don't want to fatigue or overload the respondent, right? We're going to show them product concepts, and they have to decide in each question between, look at all the features across these product concepts and make a decision. So don't overload them with too many. The experts recommend somewhere between 6 and 10 attributes. No more than 6 attributes, but definitely no more than 10 attributes is what they say. Next parameter that you need to define are how many product alternatives per question. In this case, we are showing each respondent 3 product alternatives per question. You could do 4, you could do 5. I think 3 to 5 is kind of like the gold standard. Think about it though. If you start asking 6, 7 products, respondents aren't going to be able to keep these product the attributes in mind looking across 8 products. It's just going to be too much. It's going to overload them. So try to shoot for 3 to 5 product alternatives per question. Final parameter for experimental design is how many choice-based conjoint questions are we going to ask each respondent, right? This is essentially how long is our survey going to be. Experts are recommending 10 to 20 questions. I asked 15 questions. Remember, you don't want to fatigue them. These are more cognitively intensive than your average multiple choice question, where you have to, hold several product alternatives in your head at once and then make a purchase decision by kind of, thinking about all that at once. Once we've defined how many attributes we're going to use and then each, the levels within each attribute, we can then calculate how many total product profiles are in our set, right? How many total different permutations in different products can we define with these 4 attributes? And this has 3 levels times 2 levels times 3 levels times 3 levels. That equals 54 total product profiles, right, that we can define. Now, if you think back to the amount of the other parameters that I defined earlier, that we're only going to ask respondents 15 questions with 3 product profiles per question, that's only 45 total product profiles that each respondent will see in this survey. So we're going to show each respondent 45, but we have a total of 54. And you might wonder, how do you square those two? Is it going to be a problem if the respondents don't get to see all of the product profiles? And this is not the case, because we're going to use something called a random experimental design. What this is basically you are going to randomly generate a survey for each respondent, right? Every time that you ask a CBC question, the 3 different product profiles are pulled randomly from our 54 product profile set, and they're replaced after that question. So you keep pulling them at random, and in this case we're surveying 500 respondents. In this way, you get good coverage, balanced coverage across the total profiles without needing to show respondents each product profile. So as I said, for data collection, this is a randomly generated survey, and this is very hard to do in Qualtrics manually. I don't even think you can do it manually with, manually with survey, normal survey platforms. And this is why there are specialty survey platforms out there for choice-based questionnaires. Sawtooth software, this is the gold standard. It's probably the most expensive, but it's the gold standard. I know Qualtrics has a conjoint module that you can add on, and then there's specialty softwares like I think there's one called Conjointly that specializes in this, and they probably have really nice dashboards where when you're designing the survey up front, you just you set these parameters, you tell it what are the attributes, what are the levels, and then it's going to automatically generate these surveys that you can then give to the respondents. So I would definitely recommend, in terms of data collection, to use these specialty softwares for it. I don't think that you can do it manually in something like Qualtrics. After you've collected the data, you need to get this raw data into something called a long or stacked data format. And in this case, each row corresponds to a specific product profile that a respondent saw. So this is an example of my stacked conjoint data set here. And looking at these first 3 columns, it's kind of like metadata, right? Who is the respondent? This is respondent 1, question 1, and alternative position 1, right? And we see in each question, and so you can go through, and this is the product profile that was shown in position 1. And we have 1, 2, 3 product alternatives per question. That makes sense, right? This is one of the parameters that I set earlier on. So what a stacked data set is that there are multiple observations per respondent. So one respondent is going to be on multiple rows. This is different than a respondent level data set where, this is the purchase decision that the user made. A really quick analysis we can do right up front, and we're eventually going to get to statistical modeling. It's called a choice-based model, I think. But something really quick you can do is just run a count analysis. And I'm doing this right here with crosstabs, choice, and price. What this is doing is it's telling us how many times were these attributes chosen by the respondent. And this gives us just a really surface level understanding of what our data looks like. And it's also kind of a sanity check. If things aren't making much sense here, then maybe the data was collected wrong or the data was formatted wrong. So just for example here, looking at price, here's $6 a month, 12 a month, 18 a month. And we can see that the cheapest price was selected more often than the more expensive prices, right? This is a decreasing amount of selection as price increases. This is what we would expect. Respondents want cheaper products, okay? So that's kind of a sanity check there. Cloud storage, 30 gigabytes, 2,000 gigabytes. Again, they definitely, like 30 gigabytes is pretty low for them, a low amount of times it was chosen. And 2,000 and 5,000 gigabytes is, pretty similar. So, okay, people want more storage. This is making sense. Customer support, yes, no. This is pretty evenly split here. So maybe when we run the choice-based model, we would expect that the coefficient for the importance or the utility of customer support is going to be relatively low. Maybe it's really not going to make much of a difference in determining customer choice, whether or not there's customer support. Okay, and then, yeah, cloud services, email only chosen about 1,000 times, whereas the full suite with productivity and video call was chosen 4,000 times. Again, this makes sense. So basically what we've learned so far is that customers want a cheaper product and more features, right? More storage and more services. Okay, no problem. And this is intuitive and it's a good check for us. And now we're going to get into a more sophisticated analysis where we actually fit a choice model with something called a multinomial logit regression. To define the MLogit regression formula, the dependent variable on the left side of the tilde is choice. This is the purchase decision. And then we add all of our attribute variables on the right side. These are our independent variables. And I'm including a zero term here so that the regression output does not give us an intercept term. We don't care about that. And scrolling down here, I wish that it had put this over here. This is just, these are just the p-values, but it kind of got cut off. But now we can see each product attribute now has a utility score. This estimate column is the utility score for each product attribute level. What is the utility score? This is the latent value that customers on average are ascribing to these feature levels. So we can see, and you'll notice here that some variables seem like they're missing. Where is price 6? Where is cloud storage 30 gigabytes? What happens, since all of our independent variables are categorical, they're factor variables, there needs to be a reference level in order to assign coefficients to the other levels. So the reference level is the first level of the categorical variable, and that is set to 0 for each attribute. So cloud storage 30 gigabytes equals 0. Cloud storage 2,000 gigabytes and 5,000 gigabytes is 1.18 and 1.35 respectively. What does this tell us? This tells us that 2,000 gigabytes and 5,000 gigabytes are more attractive than the 30 gigabyte option. We have to interpret these results relative to the other attribute levels. We cannot look between different attributes. I'll get into that in a second. And then the magnitude matters also. So since 1.35 is greater than 1.18, now we have a hierarchy for the importance of features. 5,000 gigabytes is more attractive than 2,000 gigabytes, which is more attractive than 30 gigabytes, okay? Customer support no is negative, so this means that it is less attractive than having customer support, right? Email and video is more attractive than just email. Email, video, and productivity is more attractive than both of those. And then price. Price 6 is the most attractive. Price 6 equals 0, utility score. And price 12 and 18 are negative, in descending order there. So they are less attractive than price 6. This is similar to the count analysis. Good. So these are lining up here. So this is really important. Utilities are kind of an interesting data type to interpret and talk about. So when you're presenting these, I want to go over just some properties of utilities and how to interpret them. Utilities must be interpreted relative to each other. Even though $12 a month has a negative utility, negative 0.84, it doesn't mean that it is unattractive in absolute terms. Yes. So $12 a month, it doesn't mean that that's terrible for everybody and nobody could see purchasing this product for $12 a month. No, the negative just indicates that it is relatively less attractive than the reference level, which is $6 a month. So that's technical, but it's important. Cannot make direct comparisons between different attributes, right? I think intuitively we would like to, compare the sign and magnitude between something like cloud storage has, so 2,000 gigabytes cloud storage is a 1.18 utility, is more attractive than having customer service, which is 0 utility. we cannot make this claim because cloud storage and customer service are different attributes, and we cannot compare attributes between one another. We have to compare attribute levels. So we can only compare 30 gigabytes, 2,000 gigabytes, and 5,000 gigabytes with each other. And we can only compare no customer service, yes customer service between one another. We can't compare the attributes between, we can't compare cloud storage versus customer service. I think you get the point. Okay. Ratio operations not supported. A ratio operation means like you can't divide it. Oh, cloud storage with 5,000 gigabytes is 2 times more attractive than cloud storage with 2,000 gigabytes. You can't do that actually. What obviously, and I've already said this, what you can do is, create kind of a rank order list within the attributes. We know that 5,000 is greater than 2,000 is greater than 30 gigabytes. Okay. Nothing new here, and you might be wondering, well, what the hell are you showing me this for? Nothing is interesting yet, but wait till we get to the preference simulator, which is a proxy for calculating, for determining market share. So I'll get to that in a second, but let's stick with this multinomial logit regression here. In the first regression model, all of the independent variables were categorical or factor variables. They all have qualitative levels. Even price. Price wasn't being treated as a numeric variable. It was being treated as having 3 discrete qualitative levels, 6, 12, and 18. That's a little counterintuitive. And what I like to do is whenever there is a numeric variable, I like to convert it into a numeric variable and then input it into the regression equation, which I do in this second model here. And we can see here. So what this basically does is it reduces the number of variables. If you remember before, everything else is the same except there was a price 12 and a price 18. Now we just have one price variable with one single utility. This will come into play a little later, but I want to go with this model. And just by the way, really quickly, you can test how well models are fitting the data relative to one another. So with LR test, it's called a likelihood ratio test. You can see if a nested model, M2, is fitting the data better than M1. Well, it doesn't fit the data better we see from this test. They're actually fitting the data equally as well, equal to one another. But I'm going to still stick with M2 because it's more of a parsimonious, it's more of a simple model with less variables. So we're going to go with M2, which is just the same as M1, except I converted the price variable to a numeric variable. Another quick analysis you can do, we already did account analysis. Another quick one is willingness to pay. And people are a little sketchy about this. It can be easily misinterpreted and people can kind of run away with it. So, report it with some caution and kind of think through, like, are these results intuitive? But now that we have an importance score for each feature level, actually what we can do is now integrate the price utility in with the other utilities, by dividing it. And now we can give a monetary value or a proxy for it for each feature level. So cloud storage 2,000 gigabytes. What I'm doing is I'm just dividing the cloud storage 2,000 gigabyte utility divided by the price utility. And this gives $8.37 a month, 5,000 gigabytes, $9.57 a month. These are going to be proportional to the utility scores that we already saw in the regression equations above. But I guess it's in a little more intuitive terms because stakeholders can see the monetary value. And the technical way of interpreting this is 2,000 gigabytes of cloud storage can command an $8.37 per month premium over 30 gigabytes of cloud storage, all other attributes being held equal. So going back up to the cloud storage, 2,000 gigabytes, dividing the utility by price, we get $8.37 premium for going from 30 gigabytes to 2,000 gigabytes. Technically, an $8.37 difference between a 30 gigabyte product and a 2000 gigabyte product, the customer is going to be indifferent, right? They're not, if it were $8.38, technically they wouldn't want to buy the 2000 gigabyte option because this extra storage would not be worth the increase in price. Okay, finally, we're to a preference share simulator, and this is also called market share simulator. This is the main analysis in choice-based conjoint studies. It's very powerful. So create a competitive market, right? We're going to be competing against AWS and Microsoft OneDrive, other cloud platforms. And so now we have a competitive set, right? And now we want to introduce our product, which is Google Drive, into this hypothetical market that we've created. And we want to know how it does. It's telling us the amount of preference that each product wins in this hypothetical market that we've created. They're also called market share simulators, but you want to be careful about market share. Market share is what percentage of the market can this product win? And this is something that obviously companies are very interested in, but you have to be careful about presenting it that way because these choice-based conjoint experiments, they're from customer surveys. It's not going to be a one-to-one exact match between real market conditions and how respondents behave there and how they're behaving and answering questions in this survey. So be careful about saying that this is a market share estimation. This is more of a preference share based on the preferences of our customers in this survey. However, experts over time have seen that preference share is a proxy, is a decent proxy for market share. Maybe not to estimate it in absolute terms, but in relative terms. So what I mean by that is that if product A wins more preference share than product B, then product A is going to likely win more market share than product B. So these simulators are directional. We call them directionally accurate. Okay, just getting that out of the way, the first thing to do is to create your hypothetical market. You need to select the competitive set, right? And we're doing this, and I'm selecting this from the total product profiles that we have above, which is 54 total product profiles, and I'm creating a competitive market with 6 products. And here are the products, and let's pretend that 16, row 16 right here is our product. Here's the competitive set. This is our hypothetical market. Now I go through some calculation here, and this is described in the writing above. We calculate the preference share that we would expect for each of these product profiles if they were to compete with one another in our hypothetical market simulator. And we can see here the percentage, this adds to 100, the percentage of preference that each product profile wins. So 35 is the winner with 31% preference share, 51 is second, and our product came in third, not bad, with 22. We can see here that, look, this first product profile only won 2% of market share. Why? Because it only has 30 gigabytes of cloud storage, there's no customer support, and it only offers email. Like, who would want that product, even for $6 a month? So that's cool, right? All right. Now we see how our product has fared in this hypothetical market. Now, the last analysis I want to do could be the most important, definitely the most interesting. For me, the natural question is, okay, now I see how it's done in this market simulation. How can I improve it? And if I do make changes to my product, assuming that the market stays the same, how will I, which changes should I make to optimize the preference share or market share in my product? And when I say changes, I mean which changes to the different attribute levels. Like, this is really going to help the product manager hone in on the feature set that optimizes for preference share and market share. And the best way to do this is with something called a sensitivity plot, which shows you that if you hold holding everything else constant in a product and changing one feature level at a time, how does the preference share change in our market simulator? Okay, here's the bar chart, and this is called a sensitivity plot. Remember that our product is 30 gigabytes. It does not have customer service. I forgot what this variable is. Email. Okay, yeah, it has email, video chat, and productivity, and it is, and we're charging $6 a month for it. Now, again, you only can do one at a time, but let's say that we want to now think about, well, what if we offer, everything else being equal, what if we go from 30 gigabytes to 2,000 gigabytes here? We would expect a 25%, around, a little over a 25% preference share increase if everything else being held equal, the market, we increase from 30 gigabytes to 2,000 gigabytes. Now that initially might be really attractive. Like, well, why wouldn't you just increase from 30 to 2,000 if you're going to increase the market share potentially by over 25%? That is because price is still being held equal. So we would have to make that 2,000 gigabyte offering still at $6 per month, which probably isn't possible, right? Or let's just assume that it's not. And then you can just kind of play around with this. But, let's say we go from no customer support to yes. Now we offer customer support on our product. You'd expect an increase of about 10% preference share, and maybe this is economically feasible for our company. Okay, let's pretend that this is a good estimation for market share. So offering customer service increases the market share by 10% for our product. Now, if we multiply the total market cap, how much is this market worth, by 10%, then we're going to now we have the increase in revenue that we can expect from changing from no customer service to yes customer service. And maybe now the company can talk, internally, is this increased revenue worth this increase in price? Last things I want to touch on here, just to summarize, this is a choice-based conjoint study. We show 3 product alternatives per task or question. Each of these product alternatives are defined on 4 different attributes or features, brand, price, something like that. We used a random experimental design for data collection, which means that you are randomly generating a survey that randomly pulls product alternatives into each question to show respondents. We did account-based analysis, willingness to pay analysis, and then we used a choice-based model, specifically a multinomial logit regression, to calculate utilities, which are the values that customers ascribe to each feature level or attribute level. And then we did a preference or market share simulator, and then based on that, created a sensitivity plot to help us hone in on the feature set that will optimize our performance in a competitive market. There are some add-on analyses that you can do. You can use a latent class multinomial logit regression to segment users based on their preferences, product preferences, and you can create, segments and then, more precisely target your product to these niche segments who might have different product preferences. So latent class multinomial logit regression, this is a way to do a segmentation on your sample, basically based on conjoint utilities. And then there is another one I want to talk about, which is called hierarchical Bayes. It's a mixed model that gives you, instead of an aggregate utility, which we calculated a utility for our sample overall. Hierarchical Bayes calculates utilities for each respondent. And this gives, more precise results. It can make your aggregate utility more precise by accounting for respondent heterogeneity. And then also going back to the previous thing, you can then use a clustering algorithm on these respondent utilities to create segments that way as well. So, kind of two different approaches to a segmentation. Last thing I want to say is it's very common to include brand as an attribute in these choice-based conjoint studies. You can think about the difference in utility between Coca-Cola, Pepsi, and Virgin Cola, which I think no longer exists, right? Coca-Cola as a brand has a huge moat. So there's a big utility score there's going to be a large utility score around Coca-Cola versus, I would guess, Pepsi and Virgin. So including brand and price are two very common attributes to include. And then maybe you want to include 4 or 5 other different feature categories to define your product alternatives on. If you include brand and price, then you can generate price sensitivity curves and then calculate price elasticity of products. Thank you.